A very good day to everyone. Today I will be presenting on a system for optimizing software regression test cases using modified n-colony optimization algorithm. Software testing finds and eliminates the defects. The testing methodology that ensures that the features are not affected by movements made in software is called software regression testing. It guarantees that any new item changes should not ominously influence the current limits, and there could be no longer other deficiency concealed in the inserted code. Software regression testing is routinely performed all through the software development and the software development lifecycle. Regardless, as the software is enormous, the number of test cases cost will increase where the test cases need to be sorted out to guarantee that higher need could be executed precisely will increase. This paper proposes an easy-to-use software system for optimizing software regression testing test cases using the m-ACO algorithm. The past papers concentrate only on creating the algorithms and experimenting with them in a simple software regression testing environment. In this study, the researcher has developed a system for the m-ACO algorithm and implemented it in the natural world environment. This system has been tested for Zasta Infotech for their ongoing project called Zata Building Web Application. m-ACO is arranged as the change in set provenance enhancement technique, which rearranges the execution grouping of software regression testing by changing the marvel of trademark bugs for picking their nourishment. The main problem statement of this study is contingent upon the test cases. It tends to be hard to start the software regression testing each time a change is made to a program and remain inside the project degree and the financial plan. Continuous software regression testing can mean structuring huge test use that take more resources to finish on schedule. Software regression testing is a time-consuming process. When software is huge, its total execution can be requires numerous hours or even days. The research objectives are to propose a system for optimizing test case prioritization using m-ACO algorithm, to research and gather information on software regression testing and test case prioritization techniques, to accomplish total or greatest fault coverage for software regression testing by selecting test data that has maximum coverage of fault, which will take the time taken to perform the software regression testing. Software regression testing is the testing that conducted on existing software to guarantee that the most recent code changes do not affect the existing functionalities of the code. Retesting all test case selection, test case prioritization, and test case minimization are software regression testing activities. Retesting everything is reconduction of overall test cases, which consumes time. Test case selection can help to pick a certain test suite to be run. Test case prioritization selects test cases based on some predefined paradigm to meet the necessary execution objective. Test case minimization technique wipe out the DRA test cases to restrict the prioritization, the number of test cases in a test tube. The mix of test case selection and test suite prioritization is called as a hybrid method. Variant prioritization measures may be associated with software regression test suite to meet a standard. Test cases can be focused on the extent that random, optimal, statement, total or additional branch coverage, total or other failures rate depends on the test case potential. As stated previously, these are the test case prioritization approaches, which are stage-based, fault-based, requirement-based, history-based, risk-based, bias and network-based, cost-effective-based, topic model-based, and also coverage-based. Test case prioritization enables a way to execute critical test cases initially as indicated by some measure and produce the ideal result. Ant colony optimization is a method used by ants to find the nourishment. It is a meta-heuristic swarm intelligence-based tool. Insects can find an improved way to exploit substances sources from their home through roundabout collaboration with every individual from their colony known as stigmacy. The choice of technique of ants is affected by the pheromone trails set by different ants on the ground since ants continue ahead of the way, which has a more raised measure of pheromone when diverge from various strategies. This paper claims a system for m-ACO algorithm. In the modified version of ACO, whenever the real ants find any food source and return to their nest with their food source, they store the food and go back to the same source until the food source finishes, where all the ants will start follow up the same trail until the food source finishes. This process declines the diversity of the kept food source. So basically, how does the proposed framework of system for optimizing test cases for software regression testing using modified ant colony optimization works? The tester will key in the details of test cases needed using the proposed framework of system, and the proposed framework of system will help the tester to prioritize and select the test cases for regression testing by generating reports. The regression testing teams will get the information from the system and further run the software regression testing. So the research methodology basically has been done using by extreme programming XP methodology. The extreme programming XP methodology begins with planning, and all iteration comprise 4 fundamental stages in its day-to-day existence life cycle: designing, coding, testing, and listening. During the planning phase, the interview was conducted with a software testing project manager of Zata Infotech to gather user requirements. The prerequisites have been changed over into iterations that cover a little of the required functionalities. A mix of iterations give the client the final, usually functional product. The next stage is followed by designing the main features of the code for the proposed m-ACO system defined. A simple design has been created. After design is completed, the proposed method is started to be coded. The testing is typically directed not after the last or moderate item is done, but alongside the technique of the code composing. At the final stage, the XP feedback from the project manager of the Zata Infotech has been gathered. So this figure is actually explains the overall research methodology that has been discussed previously. As we can see, it has been started from the research design and ended as a small release. In between, the user stories has been collected as the requirements, and also it has been implemented in the release planning. The framework of the system that has been developed has been successfully developed, and the result has been collected by having a comparison of time taken for software regression testing conducted for a project Zata Billing Web application in a startup company, Zata Infotech Private Limited, based from India. Zata Billing Web application helped to carry out raise the invoice in a better, easy way with automated software. Zata Billing Service trump card is to attract the business customer and promise high-level certification. It also provides GST billing services to small and medium scale level businesses. Software regression testing has been carried out for Zata Billing Web application using the developed framework and compared the time taken for software regression testing with m-ACO framework and without it. The time taken to complete the software regression testing using m-ACO framework is 45 days, whereas without m-ACO is 90 days. It can be seen in this graph where the manual software regression testing took about 90 days and the software regression testing with m-ACO framework only took about the 45 days. The main functionalities that has been tested during the software regression testing is shown in the table below. We can see below are the test cases that has been performed in software regression testing. We have about 13 test cases to be conducted. This developed system will help to prioritize the test cases and select the most important and prioritized test cases, which will reduce the time taken for the software regression testing. This will be further shown in the upcoming slides. As we can see, the main framework or system functionalities that is upload, view, and also calculate. The functionalities, the system consists of these three main functions, which is upload, view, and also the calculate. This is the main interface of the system. First of all, whenever the tester or the user of the system open the system, the user has the choice to upload whether new or existing test case report. While uploading whenever the user uploads the new test case report, the iterations, the total test case number, the total test case fail, everything will be filled out according to the report. And also the user need to give a name of the report name, and they can choose the report file over here by browsing wherever their report has been saved. And also the total test cases that has been passed will be populated. Once all have been successfully filled up, the user can submit in order to have a further action. Whenever the user submit, once the test report uploaded, a pop-up will be shown indicates the successful test report has been uploaded. So, in a view section, once the test report uploaded, it can be viewed in the view component, as we can see in this system. In order to calculate the test report prioritization, the user need to select the report name that has been uploaded just now and click the calculate button. After the report selected, the tester can click the calculate button. The APFD will be calculated for the test report selected and prioritization report will be generated, as we can see in this slide. And in this slide, we can see the test cases before prioritization method applied. We can see there is 13 test cases overall. After the prioritization has been applied, the system will help the tester to prioritize the test cases accordingly with the execution time and also the test case number. So basically, the main source code of calculation of APFD has been shown here. The primary measure utilized for focusing test cases in this proposed m-ACO method depended on accomplishing total or greatest fault coverage. Then the outcomes were investigated using APFD metric. The APFD metric is utilized to access the average fault detection rate per level of execution of the test suite. We can see here the notation of APFD computation are the T equals to test suite to be assessed. m number of faults in application under test, and total test cases in a test suite, tfj area of first test case in a test suite, t that reveals the fault j. Software regression tests help us to make sure the function of the software remains the same before and after the changes has been made to the code. It is a time and money concentrated interaction. Test case prioritization is extremely useful and sensible software regression testing procedure to limit the amount of test cases in a test suite by rearrange the test cases in a neat request, which viably builds the likelihood of software code coverage and pace of fault discovery through the APFD metric. This paper is presented a framework or system for a m-ACO, which is an altered form of ACO and colony optimization algorithm for the test case prioritization. m-ACO works by changing the procedure utilized by regular ends for determination of their food source. The research further work will be discussing on the developing the framework of system as a mobile application to ease the software testers to conduct their software regression testing anywhere or anytime. Thank you. That's all from me.